Welcome back. This is another video for solving polynomial equations like you'll see on your assignment, on your Edulastic assignment. In this case, we're going to talk about what we call quadratic forms. These aren't necessarily quadratics, but they have a form that could easily be turned back into quadratics. You're going to see problems that look like x to the fourth minus 7x squared plus 12 equals 0. A quadratic equation has a degree 2. This one obviously has degree 4, so it's not quadratic. But because we have a fourth degree term and a second degree term and a constant, we can easily turn this into a quadratic using a simple substitution. If I let u equal x squared, then square both sides, I get u squared equals x squared squared, which is x to the fourth. Then I can plug in, substitute u squared for x to the fourth and u for x squared. And now I have a quadratic equation in terms of u instead of x, which you have learned to factor. Quadratic equations that look like this: two numbers that multiply to make 12 and add to make negative 7, or negative 3 and negative 4. So that means this factors to u minus 3 times u minus 4 equals 0. We can set each one of those factors equal to 0 and get u minus 3 equals 0, u minus 4 equals 0. Now we didn't really care about u. We started a problem looking for x. We have to find x, so we're going to re-substitute. We're going to make a substitution for x squared back in for u to get x squared minus 3 equals 0 and x squared minus 4 equals 0. Both of these are easily solvable. Add 3 to both sides and get x squared equals 3. Take the square root of both sides to solve and get x equals plus or minus the square root of 3. Add 4 to both sides here and get x squared equals 4. Take the square root of both sides and get x equals plus or minus 2. This is 4 solutions. X equals the square root of 3. X equals negative square root of 3. X equals 2. And x equals negative 2. 4 solutions to a fourth degree polynomial equation, just like the fundamental theorem of algebra tells us. Let's do another one. Let's do x to the fourth minus 5x squared minus 6 equals 0. Again, we see that we have a constant, next square term, x to the fourth term. We can make the substitution u equals x squared. It follows then that u squared is x to the fourth. Substitute, get u squared minus 5u minus 6 equals 0. Now we're in a quadratic form. We can look for two numbers to multiply to make negative 6. Same two numbers add to make negative 5. Negative 6 and 1. Multiply to make negative 6. Negative 6 and 1. Add to make negative 5. So this factors to u minus 6 times u plus 1. Set the factors equal to 0. Recall that we're not looking for u, we're looking for x, so we plug x squared back in for u. Solve these equations, and we get x squared equals 6 when we add 6 to both sides. Take the square root to get x equals plus or minus the square root of 6. Subtract 1 from both sides and get x squared equals negative 1. Take the square root of both sides to solve. We get plus or minus the square root of negative 1. We don't leave this in terms of negative under the square root. So this is square root of negative 1 is just I, the imaginary unit I. So we have 4 solutions. X equals plus or minus the square root of 6. Oops, sorry. Let's just do square root of 6. Negative x equals negative square root of 6. X equals I, and x equals negative I, to get our 4 solutions to our fourth degree polynomial equation. And here again, not every solution is real. These two solutions are both complex or imaginary solutions. These numbers are real solutions, but they're irrational solutions. And notice that these numbers always come in what we call conjugate pairs. The square root of 6 will never come by itself in a polynomial equation. It will always come with negative square root of 6. I will never come by itself. It will always come with negative I. These come in what we call conjugate pairs, which means if you have a solution in the form of a plus b times the square root of c, then it must also come with a minus b square root of c. Or if you have an a plus b times I, it has to come with an a minus b times I. These types of solutions, both the irrational and the imaginary, come in conjugate pairs because they come from quadratic factors. Let's see, is there anything else you need to learn to help you today? One thing you saw in your assignment is you saw some geometric figures, three-dimensional figures especially. Just recall that you can write those as a polynomial equation in the word problems, and if you divide by one known dimension, then you can get the other dimensions, and you can factor using that and solve and answer the questions. That's all you got for this lesson. Y'all can work on your Elastic now.